Hi, welcome back. And look at the puzzle today. It's kind of a simple one. You have to find out what is the number that best fit these slots. And you have a kind of an odd arrangement where you can find equations on the vertical and equations on the horizontal line. So try to figure out how to solve it, how to find the number that best fit the slot that have the question mark that the little Pac-Man guy here is pointing to. We are working on chapter number 5, exponents, polynomials and polynomial functions. This is kind of a review topic about factoring by special products. You're going to need to understand and to remember how to factoring polynomials. So we will apply a bit later when we work with rational expressions. Objective number 1, factor a perfect square trinomial. A trinomial that is the square of a binomial is called a perfect square trinomial. And we have the formulas that we will apply in this situation, which are a squared plus 2ab plus b squared is equals to parentheses a plus b squared, and a squared minus 2ab plus b squared equals parentheses a minus b squared. Those are the formulas. And let's have a look at how to apply, how to work on an example. Factor x squared plus 12x plus 36. And the formula that we're going to use here is a squared plus 2ab plus b squared. Right? This is the formula which is equals to a plus b squared. We have to identify, find out who is A, who is B, and then we check. We can see that A is going to be X, right? A is X. We can see here that B is 6, because we have 36 is 6 squared, so B is 6. Now we have to check if this fits. If this is going to be equals to 2 times A times B. And let's try this out. 2 times AX times B is 6 is 12x. Yeah, it's the same. It fits. That means we can apply this formula. See? Because we have this form, this kind of a polynomial that we can fit into the perfect square trinomial. The answer or the solution is going to be A, which is x, plus B, which is 6, squared. This is the solution or the answer to factor out the polynomial x squared minus plus 12x plus 36. Now let's work on another example. And we have here 16x squared minus 8xy plus y squared. And we have to find out if this is a perfect square trinomial. The formula that seems to fit here is a squared minus 2ab plus b squared, which is going to be equals to a minus b squared. Let's check if it really fits. Well, we need to have a squared here. That means a needs to be equals to 4x squared. That's fine. 16x squared we can write as 4x squared. Now b, well, let's check if it fits. We have y squared, so we can make b equals to y. And here in the middle, we need to have negative 2ab. Negative 2 times a is 4x, and b is y. And comparing this, this one with that, negative 2 times 4, negative 8 times x times y, yes, is the same, so it fits the perfect square trinomial. It is a perfect square trinomial. That means we can write down the answer as a for x minus b y squared. This is our answer. This is how we factor out 16x squared minus 8xy plus y squared. But just because this is a perfect square, this fits the form. And working on another example, now we have factor 4m exponent 4 minus 4m squared plus 1. Well, again, we need to check if it fits the formula. And the formula that we will compare, that we will check here is a squared minus 2ab plus b squared, which is equals to a minus b squared, right? So, checking out, comparing, we have 4m exponent 4. Well, we can write as a square, and 4 is 2 squared, so we can write 2, and m exponent 4 is m squared. M squared exponent 2, right? So a is going to be 2m squared. And b, well, b is 1, 1 is 1 squared, so b is 1. And here in the middle, as the middle term, we need to have negative 2 times what? Times 2m squared times 1. Let's compare, check if this is the same. And comparing with 4m squared, check this out. Negative 2 times 2, negative 4, m squared times 1, negative 4m squared. Yes, the same. So this fits. This is according to the formula of the perfect square trinomial. That means we can apply that solution, this way of factoring out. And a is 2m squared, b is 1 squared. That is the answer, that is the solution. Now, next is another example, and now we have 25x squared plus 50x plus 9. Well, first step, always check if it fits the formula. And the formula for this one is going to be a squared plus 2ab plus b squared equals to a plus b squared. And first, check if the polynomial, the trinomial that we have here, it fits the formula. 25x squared. Well, we need to find a, and 25 is 5 squared, and x squared, okay, x, 5x squared. Okay, we found a. Let's find out b. b is going to be 3 squared, right? b equals 3, because 9 is 3 squared. Now let's check here this middle term. It needs to be 2 times a, 5x, times b, 3. And let's compare. Let's check if this is the same thing as the original, the term that you have in the original equation. And check this out. 2 times 5, 10. 10 times 3, 30. So we have here 30x. On the original equation, we have 50x. That means this is not, let me write here, not a perfect square. It doesn't fit the formula. It's not a perfect square. To be a perfect square, we should have in the middle plus 30x. Instead, we have plus 50x. Okay? So we cannot apply this. And let's work on another example. Now we have 16x squared minus 8xy plus y squared. Compare with the formula. The formula that we will apply here is a squared minus 2ab plus b squared equals a minus b squared. Let's check if it fits, right? And first here, 16x squared. Find a that we will square. What's going to be the value of a? Well, 16 is 4 squared, x squared, well, x. Perfect. A is equals to 4x. Now check b. B is going to be y. Y squared. Cool. Now the middle term. We need to have negative 2 times a for x times b, y. Comparing this with the original one. Let's check if they fit. They are the same. Negative 2 times 4, negative 8, xy. Yes, they are the same. That means we can apply the formula. And we can write down that this is equals to a for x minus b, y squared. This is the answer. This is how we factor out the given trinomial. Alright, now let's move to the next objective. Factor the difference of two squares. A binomial is the difference of two squares if 1, both terms are squares, and 2, the signs of the terms are different. For example, and we have here 9x squared minus 25y squared. Yes, they're perfect squares. Difference of perfect squares. And negative c exponent 4 plus d exponent 4. Yes, it is difference of perfect squares as well. The formula that we will apply, that we will use in this case is going to be that one. Let me write here so we can remember. A squared minus b squared equals a plus b times a minus b. You don't need to memorize the formulas. You can have, and I suggest you to have a piece of paper, like a formula sheet, where you write down all the formulas that you need, that we are studying. Check this example. Do you think this will fit the formula? And let's write the formula again. A squared minus b squared equals a plus b times a minus b. Well, we have a as x squared, and we have b. B is going to be 3 squared. 3 squared is 9, right? So we can write ax plus 3 times x minus 3. That is how we factor out x squared minus 9 is equals to x plus 3 times x minus 3. Check this other example, and does this example fit the formula? Well, I don't know yet. Let's try, let's think about it. A squared minus b squared equals a plus b times a minus b, right? Can we find the a here that is going to be squared? Can we find the b here that's going to be squared? Well, a is going to be 4 is 2 squared, so 2 x squared x, and b is 1. So it fits the formula. We can write this is equals to 2x plus 1 times 2x minus 1. Cool? Moving to the next example, we are working with difference of squares. And we need to know the next example if it fits the formula. We need to compare, we need to check and see if it fits the formula for perfect squares. A minus b squared equals to a plus b times a minus b. And a is going to be what? Y, right? Y squared. And b minus 16 over 25 is 4 over 5 squared. So yes, we can find b. B is 4 over 5. That means fits the formula. We can factor out, it can write as y plus 4 over 5 times y minus 4 over 5. Oops. That is the answer. That is how you factor out y squared minus 16 over 25. It's equals to y plus 4 over 5 times y minus 4 over 5. Alright, and we can move on to another example. And now we have 36a squared minus 49b squared. What do you think? Do you think this fits? This can we apply the formula for perfect square, difference of perfect squares? I don't know. We have to check. Remember, this a and b that I'm writing here is the a and b of the formula, not the same a and b of the polynomial, the binomial that we are working, right? So a squared minus b squared equals a plus b times a minus b. Oops, a minus b. Okay? And this is the a of the formula. Can we find the a of the binomial that we're working with? Well, 36 is 6 squared, and a, and 49 is 7 squared times b. And yes, we found here the a of the formula is 6a, the b of the formula is 7b. That means 6a plus 7b times 6a minus 7b. Okay, now we can move to the next example, and that is interesting because when you try to check and compare with the formula, it doesn't fit at the first sight, right? Because you have a squared minus b squared equals a plus b times a minus b. But here we don't have a square, we have a cube. And that's a big problem, right? We need one step before we can apply this formula here. We need to find if we can factor out something from both terms. And I can see we have x cubed and we have x. It looks like we can factor out x. X times 4x squared. 4x squared minus 49. And now we can factor out this this binomial here, this inside the parentheses, using the formula, because I think it fits. Look, we can say that a is 2x squared minus, and b is 7 squared. So a is 2x plus 7 times 2x minus 7. But remember, we have this x here that we factor out. That means the solution is going to be, for factoring out this polynomial, is x times 2x plus 7 times 2x minus 7. Do you understand this? Because we have this x, and the formula is applied only to the polynomial inside the parentheses. So we keep the x, and we can factor out the polynomial. Moving on to another example, another good example that we have here. Check if it fits our formula. A squared minus b squared equals times a minus b. And 49 is 7 squared. X, b is going to be x squared. That means equals to 7 plus x times 7 minus x. Great, yes, perfect. This is the solution. This is how we factor out 49 minus x squared. One more example on the difference of squares. X plus 1 squared minus 9. Yeah, the formula is a squared minus b squared equals a plus b times a minus b. We can say that a equals x plus 1. Nice. Squared minus, and b, 9 is 3 squared, so b equals 3. Right? X plus 1 plus 3 times x plus 1 minus 3. That's it, but we still have work to do here. We need to combine like terms. We have some numbers that we can combine. X, 1 plus 3, 4. And x plus 1 minus 3, x minus 2. Okay, this is the last example. Now we will, for difference of perfect squares, now we will move to the next objective, is to factor the sum or difference of two cubes. I will write down the formula so we don't forget. Is a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. The other formula is a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. So now we will learn how to apply, how to use these formulas. And we have an example, x cubed plus 1. We probably can fit on the formula a cubed plus b cubed, which is equals a plus b times a squared minus ab plus b squared, right? And a is going to be x. And what about b? Well, 1 is the same thing as 1 cubed, or 1 squared, or 1 exponent, any number. B is 1. X plus 1 times x squared minus x times 1x plus 1 squared, just 1. This is the answer. This is how we factor out x cubed plus 1. Now let's work this example. Y cubed minus 64. And we can write this expression as y cubed minus 64 is 4 cubed, right? 4 times 4, 16, times 2, 5 times 4, 64. And check the formula. A cubed minus b cubed equals a minus b times a squared plus ab, plus ab plus b squared. This is the formula that we will apply. So y cubed minus 4 cubed equals a is y minus 4 times y squared plus y times b, 4y plus b squared 16. Okay, this is the answer. Just need to apply the right formula. Another example, and now we have 64y cubed plus 1, and we can rewrite this as 4y cubed plus 1 cubed, right? So we have the sum of 2 cubes, and the formula that we will apply here is a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. You don't need to memorize those formulas, right? You just need to have, and I suggest you to have a piece of paper with all the formulas that we are talking about, and in the future, when we're working with rational expressions, we're going to need to simplify rational expressions, so you know what kind of formula you will need to use, you will have to apply. Okay, so have a formula sheet and get all these formulas prepared. A is going to be 4y, right? Let's just repeat. 4y plus b is 1 equals 4y plus 1 times 4y squared is 16. Y squared minus 4y times 1, 4y plus 1 squared is just 1. That is the answer. This is the right answer that we're looking for. And another example. So we have another example. X cubed times y exponent 6 minus 27 times z cubed. We need to try to make this expression fit the formulas that we have available to apply. And the formulas for the sum or the difference of cubes are a cubed minus b cubed or a cubed plus b cubed. So let's try to make this fit. And we need to have a cube, and this is a subtraction, and we need to have another cube, right? So what is going to be if we apply the exponent 3? We will have x cubed minus y cubed. So we need to have here inside x and y squared, right? x and y squared. And on the other side, on the other parenthesis, 27 is 3 cubed, right? So 3 and z, just like that. That's the right shape, the right form, so we can apply now the formula that we know for cubes. A cubed minus b cubed equals a minus b times a squared plus ab plus b squared, right? So now I can apply the formula just to make sure we're doing the right thing. X y squared, this is a, right, cubed minus 3z is b cubed equals, well, a x y squared minus b 3z times a squared x squared y 4 plus ab, a is xy squared and b is 3z, so 3xy squared z plus b squared 9 z squared. That is the answer. If we apply correctly the formula, this is the answer that we're looking for. And this finishes, is the last example of chapter 5.7. Again, this is a review, is to work on some special cases of factoring that we will apply on the next section when working with rational expressions. And what about the puzzle, today's puzzle? Did you find the answer for today's puzzle? You have to make sense of this arrangement, and we can start on this number 2 here, that there is the only number that we have available here in the middle, right? So something minus 2 is 10. This something needs to be what? It needs to be 12, right? 12 minus 2, 10. And then check the equation on the vertical. 12 plus something equals 20, so this something here needs to be 8. Now we have on the vertical again 8, the horizontal, I mean, the horizontal 8 minus something equals 6. This needs to be 2. And finally, vertical again, 2 plus 2 equals what? Equals 4. That means the answer is 4 for today's puzzle. Thank you for watching, and see you on the next section.